So in this question, we've got a water tank, and this water tank has a height of h meters and a radius of r meters, and it's got a spherical shaped top, and it's a cylinder for the rest of it. Now the volume of it is 6 meters cubed. Now we've got three things we need to do here. We need to show the surface area is 12 over r plus 5 pi r squared over 3. So we're going to have to do some manipulation to try and get to that. We want to know when the surface area is minimised, what is the radius, and we also want to calculate the minimum of the surface area that it could be for any sizes of the radius. So how are we going to go about that? Well, first of all, we're given the volume is 6 meters cubed. Now a shape like this, we can calculate the volume by using its formulas. So here, part A, we'll have the volume. Now we've got a spherical bit at the top, but it's only half of it. So volume of a sphere is 4/3 pi r cubed. So it's 4/3 pi r cubed, but it's only half of it. So we take half of that. And then we've got this cylinder bit here. So the volume of a cylinder is the area of the face here, which is pi r squared. And then we multiply that by the height h. So that's add pi r squared h. Okay, now we can simplify this off a little bit. So half of 4/3 pi r cubed is 2/3 pi r cubed. So that's 2/3 pi r cubed plus pi r squared h. Okay, now in this formula here, to show the surface area, we can see there's actually no height. So what we might want to do is to take out the height for this formula. So let's have a look at that. Well, we've got 2/3 pi r cubed plus pi r squared h. Now we know that this equals 6. As the volume is 6 meters cubed. So let's try and get this h isolated, and then maybe good things can happen and we can get to this. So if I move this to the other side, I'll get this pi r squared h on its own. So now I've got, let's just put that like that, pi r squared h. That now equals 6 minus this 2/3 pi r cubed. Okay, now to get the h on its own, divide everybody by pi r squared. So divide this side, I'll be left with h. Divide this by pi r squared, I'll have 6 over pi r squared. And then I've got 2 pi r cubed over 3 divided by pi r squared. So now I've got 2 pi r cubed divided by 3 pi r squared, because the 3 is here. So 3 pi r squared. Okay, now just simplify that off a little bit. I can just cancel out a pi and an r squared in the numerator. So now height equals 6 over pi r squared minus 2r over, well, if we take a pi r squared out, we're just left with 3. Minus 2r over 3. Okay, so that's to do with the volume. We need the surface area. So we was given the volume earlier, so that's why we had to work with this. So now let's work with the surface area. So surface area, if I put surface area like that, surface area of this, well, again, we've got half of a sphere. Surface area of a sphere is 4 pi r squared, but we've only got half of it. So we half that, so that will just become 2. Okay, now we've got this bit here. Now we've got a circle there, so that's just pi r squared. So that's plus pi r squared. And then we've got this bit here, this side, the walls of the sides. So that will be whatever the diameter is times the height. Well, the diameter will be 2 pi r and times that by the height. Okay, now I can see straight away here 2 pi r squared plus pi r squared, that's going to give me 3 pi r squared. So now I've got surface area equals 3 pi r squared, and then I've got 2 pi r h. Now I've got the h as this here. So instead of using h, I can substitute this, and this formula doesn't use h, so therefore I can eliminate the variable h from our calculations. So that was our goal right from the beginning. So to substitute h in here, 2 pi r times this. So 2 pi r times 6 over pi r squared minus 2r over 3. Okay, right. Let's do some simplifications. So now I've got 3 pi r squared. Now I've got 2 pi r times 6. That's going to give me 12 pi r. And then divide that by pi r squared. And then here I've got 2 pi r times minus 2r. So that's going to give me minus 4 pi r squared. And then divide that by 3. Okay. Now I can see here pi r will cancel out here. And that will cancel out and just leave me with 1 of the r's. Now looking here, pi r squared, I've got 3 here and minus 4/3 here. So if I do 3 minus 4/3, I can put these together because they're going to be like terms. So now that's going to give me, so 3 minus 4/3, well that's the same as 9/3 minus 4/3. So that's 5 pi r squared over 3. And then plus 12 over r. So there we go. I've got exactly what I wanted here. I've shown that the surface area is this. So that's what I've got there. So that's all good for part A. Okay, now I need to work out part B. So let's do part B. Take this off the board and let's go for that. Okay, so part A finished. Part B. When is the surface area is minimised, what is the radius? So to do that, we need to take the derivative of this and set it to 0, and whatever the resulting radius is for that, so solve for r from that derivative, that should give us the surface area minimised value for the radius. So let's just write that up. So part B. So that's our area, we worked that out in part A. So what we want is the derivative of the area with respect to the radius, because the radius is what we want. So we want the derivative of the area with regards to the radius and set it to 0, and then solve for our variable r. So let's put this value in there for our area. So now we want the derivative of 12 over r plus 5 pi r squared over 3, all with regards to r, and then that is going to be 0. Okay, so let's take the derivative of this. Well, 12 divided by r, that's 12 times r to the minus 1. So if I wrote that as 12r to the minus 1, then what I can do is to take the derivative, I'll multiply the coefficient by the power, so that will then give me minus 12, and then reduce the power by 1, so that becomes minus 2. So minus 12, so r to the minus 2 becomes divided by r squared. So that's our first derivative for this part here, but we've got this one here. So 5 pi r squared over 3, so our coefficient here is 5 pi over 3. So taking the derivative, I'll multiply everything by 2 at the front. So that's going to give me 10 pi over 3. So plus 10 pi over 3, and then reduce the power by 1. That's just going to give me an r. And then set that to 0. So now, got the derivative, set it to 0. Let's see if we can solve for r. So let's bring this onto the other side. So now I've got 10 pi r over 3 equals, well this is a minus, so now I've got positive. Okay, well, multiply both sides by r squared. That'll get rid of this fraction here. So now I'll have 10 times pi r cubed equals 12 divided by 3. Now, what I can do now is multiply this side by 3. So now 10 pi r cubed equals 36. Now to get r cubed on its own, let's divide both sides by 10 pi. So r cubed equals 36 over 10 pi, which, well, I can simplify this off 18 over 5 pi. So then r, my radius, equals the cube root of 18 over 5 pi. Okay, now plug that in to a calculator. The positive value I will get for that will be 1.0464 approximately. So that's approximately 1.0464. And our units here are in meters, radius is in meters, so that's in meters. So what is the radius minimised? I've got 1.0464 meters approximately. Okay. Now, what is the minimum surface area at that radius? Well, all I need to do is to plug that value into here and I'll get the answer to my part C. So let's just draw a line along here, leave that there. Now let's go for part C. So what's my area when it's this value? So let's just plug the values in. So area equals 12 over 1.0464 plus 5 pi times 1.0464 squared divided by 3. Okay, right, we can just plug all that into the calculator and we'll get area is approximately 17.201, and the area, because it's area, it's in meters squared. So always remember to put our units. Okay, so that's our answer to part C. That's our answer to part B, and we proved part A in the previous board before we rubbed out. Okay.